Okay, so let me share the screen. How about now?
Yes, I can see your screen.
Okay. So in this session, we'll cover object-oriented programming concepts, uh, classes, and decorators. Okay, so this forms the object-oriented programming. In object-oriented programming, we have the concept of class. Okay, a class and objects, or classes and objects. Okay, so what is a class? A class in object-oriented programming is a template of an object. Okay, meaning you have templates which have the definition of uh, properties and methods which will bind the data and the function together. Okay, a template, for example, in object-oriented programming is like in this picture, there's a cookie cutter. Okay, the template of that cookie cutter is having the profile, okay, of the cookie cutter, which is used to create several cookies. Okay, several cookies can come out of this cookie cutter, right? So a class is a template of an object, okay, and the a template of that object will have properties and methods. So in this case, the profile of the cookie cutter is something similar to the property. Okay, all the cookies coming out of this cookie cutter is called objects of that cookie cutter. Okay, these are cookies, right? So class is like a cookie cutter and the DAO, and the cookie cutter operating on that DAO will create multiple cookies. Okay, so these are like objects. Okay, in terms of other definitions, here there could be multiple cookie cutters. Okay, so each of it has different profiles, right? One is like an elephant, another is like a bear, uh, some are like a star and heart shape. So these are all different templates of objects. Okay, they have different properties and they can have different methods. Okay, so so with these, they could create this could create an object, another could create another object, so on. They could create multiple objects. So a class is a template of an object, whereas object is an instance of a class. Okay, it is one unique occurrence. Okay, it's called an instant of the class. This cookie is different from this cookie. Okay, both are the same shape, but they are different objects. Both are the same, they're coming from the same cookie cutter, but they are different objects. Okay, so object 1 is red, object 2 is like some design blue and red together, and object 3 is just a cookie without any designs. Okay, but all of them have same properties. The properties could be different, but you see the profile of this cookie cutter is here. So the property of the class is in the object. Okay, is an object which is an instance of the class. Okay, so we have multiple objects. Each of them have the same properties and methods of the class, but they are separate instances. This is one red cookie. This is another one. This is another blue and red cookie. You look at it in another example, a class is like a blueprint of the house. Okay, the blueprint has certain definitions. It has certain properties. Here, the blueprint of the house uh, is shown below. Okay, and it has certain values. It has some properties And of course, we'll see some methods, but this is a definition which is the class. Okay, a blueprint of the house is a class. But with this blueprint, I could make multiple houses. I have a yellow house, the red house, the blue house, and orange house. So in fact, all of these houses were built from the same class, same blueprint. Okay, and each house is an instance of this. It's an instance of this class. Okay, each house is an object, but what is an object? It's an instance of the class. Okay, still further example. I have sketch pens here. Sketch pens, each of them have different colors. Okay, the sketch pens are like they all look this. They all have different properties. They all have different properties. Okay, which is color. Okay, but the color itself is a property of the class. Okay, class of sketch pens. Now my class could be called sketch pens, and there could be a property called color. Now the color property of each of these pens are different. Okay, the property name is color. Okay, and what can the sketch pen do? It can write, it can draw. Okay, so these are methods of the sketch pen. Okay, with the sketch pen I can write, I can draw. Okay, so these are called methods, or methods. Another name of methods is functions. What you learned just now is functions, right? So functions are also called methods. Okay, so when you're using that functions inside a class, it's given a name method. Okay, the reference to it is method. So what is my takeaway here? This is sketch pen. I have a property called color. I have a method called write. I have another method called draw. Okay. Another example here are paper clips. The paper clips is the class name. Color is the property. Okay. Color is a property, and these are three separate paper clips with different colors. These three separate objects. Okay. And so this class name is paperclip. Okay. Of course, you can clip the paper. So that is a method of that class. With the paperclip, you can clip papers, right? So this is a method. Now, classes have a definition. Okay. So a class is a template of an object. Okay. What does the class represent? It represents data. Class represents data. So simply put, I can represent a class called pen, book, car. These are all my classes. Okay, you have each of which is a representation of data. Okay, and we take a look at the concept called encapsulation. Encapsulation means I'm going to have a class created which wraps or binds the properties and methods together. Okay, which binds the properties and methods together. So as in our last example, I have a sketch pen which has got color, which is a property. Okay, and write and draw methods. Okay, so what does a class do? It binds properties and methods together, and this is what the concept of encapsulation is. Encapsulation means you are binding a property and method together. Now, here are some examples. Pen is a class name. Pen can have a specific name, can be a fountain pen, it can be a gel pen or ink pen. It has got a name, okay, and it's got a color, okay. It could be a red pen, blue pen, like that. Okay, so these are some properties of the pen class. So properties are what you could define inside a class. Properties can be defined for a pen class as name, color. Okay, simply put, you can think of it like a variable. Okay, when you define a class and you have a variable name, that is what is called as a property. Okay, and then this pen can write and draw. Okay, so these are some methods. Book has properties title, author, year of publication. Okay, title is a property, author is another property, year is another property. Okay, and title can be a string, year can be a number. Yeah, it doesn't matter the data type, but we are defining the class to have these properties. And number of pages can be a method, publishing is a method. A car, yet another example, car as a name, okay, a model, model a year number. A car can have a color. Car can start, stop, accelerate, and brake. These are methods of the car class. Person can have first name, last name, gender, date of birth. Okay. Methods are age. Okay. A person can have age, which is a number. Okay. And a person can talk, walk. So getting to think in terms of uh, classes and objects, where we're using the concept of wrapping properties and methods together. Okay, this approach of programming is called object-oriented programming. And why is it is why do you need object-oriented programming? What is the benefit of doing this? We are creating our own data type. Okay, when we looked at the earlier data types like string, integer, float, and so on, then we developed it into, okay, Boolean, right? So these are string, integer, float, Boolean. These are some basic data types. These are provided by Python. Then we looked at some advanced uh, types like lists, and even we'll look more into a dictionary. Okay, so we have some advanced data types, but these are offered as basic Python. Okay, now when you look at creating your own data type, that's when you'll use classes and objects. Okay, I have my own data, user. Okay, user is my class which I'm creating. What will it have? It'll have username as one property and a password as another property. Okay, so these are properties of my own class. And user, what can the user do? Log in, log out. Okay, these are methods of that class. So while I create my own data type and store my own data, that's when you use classes and objects. Okay, so classes here is the class we're talking here is user. Okay, username, password, properties, and methods. So student as a name, date of birth, gender. Okay, date of name, yes, date of birth is some date. Gender, male, female, could be Boolean, right? So, and student can read, write. Okay, similarly, teacher. Okay, same like that. Teacher has a different method. Teaches, writes. Okay, vehicle. A vehicle can have a name, a registration number, an engine number. A vehicle can have a model, the number of cylinders. These are all properties of the vehicle. I create my own. Okay, and then a vehicle can accelerate, brake. Okay, animal can have a name. It can have a color. Animal can have number of legs. Okay, animal can run. A bird, like so on. Name, color, wings, number of wings. It could have two wings. Okay, bird can fly. Okay, you're getting to think in terms of a class as what are the properties of the class and what can this class do. Okay, so here is another example of a course, like a course name, a duration, start date, end date. Here you're defining your own data type, okay, called course, which can have these properties. And the course can have start, it can have start date, it can start the course, it can, the course can stop, okay. A class, a specific class has a number, okay, section, size. You could pretty much define anything inside properties. And again, you can define your own method. So is this clear so far? Sriram?
Yes.
Oh, very good. Okay. So the relationship between the class and an object. So here, let's take one example, student. One is an object. So the relationship between the object and its class is student one is a student. Okay, the relationship is a student. So the relationship between an object and a class is a type of a relationship. An object is a class. Object is an instance of a class. Okay, student 2 is a student as well. Teacher 1 is a teacher. Teacher 2 is a teacher as well. Now we'll look at inheritance in later session. Okay, we'll not go there right now. Okay, so let's look at objects a little further. Now here is class. I have class and an object. Okay, uh, I can have multiple instances of that class. Okay, each instance is called an object. Okay, so object is having its, okay, class is having its properties and method. This is the definition. Okay, this is the definition. A class is having properties and methods. Now, object is an instance of the class. The object itself is going to have the same properties and methods by the definition of the class. Um, However, this particular instance of that object will have properties and methods which you can set. Okay, this is student 1. Okay, student 2 could have his own name different and its method name is inherited from the class. So student 1, Sriram, student 2, just like that. Okay, so object will have properties and methods. Okay, a class can have properties and methods. Now going back to the cookie example, this was a red cookie and this is a blue cookie here and with some design. This is the cookie cutter. Okay, so cookie cutter will have the property and method. The object conforms to the same property and can use the method. Okay, what is being defined in the class. Okay, but here is object 1, object 2. These two have different, let's say, color method. These two have different colors. Okay, this instance is different from that instance. Okay, now the class by itself is one entity. Here the object itself is also another. These two are separate, right? The cookie cutter is not the cookie. Okay, the object is a member of that cookie cutter class. It's a member of a cookie cutter class, you can say. Okay, this property the name of these properties are the same. However, the cookie cutter is not the cookie, right? Cookie cutter is not the cookie. The class has its class has its properties, object has its properties. So when I tell class properties and methods, this is the object properties and methods. Okay. So keep in mind the class and the instance of that class are not the same thing. This is an object, this is a class. Okay. So that's right. So further, have classes serve as instance factories. Okay, just give me a moment. So class serves as an instance factory. So that's just another way to tell what does a class do. The class is like a factory where they can create multiple cars. So let's take a car factory. So there are multiple cars coming out of that car factory. So the factory itself is like a class. So they are serving as instance factories. That means they're serving as factories for that car, right? Each car is different. Okay. If classes are a cookie cutter, okay, instance of the class, instance of the class are the cookies, right? So here is now we're getting to a little bit more detail here. An object can have object dot attribute expression, object dot attribute. Let's say car dot model. Okay, that model is a property. No, that's also what it meant by attribute. Properties can be called attributes. Okay, so the reference of let's say student one dot name is this object expression. Okay, so student one dot name. So here what's happening is I have a class class keyword before the name of the class. How do you define a class? This is as simple as it gets. Class is a keyword, one space, and the name of the class, colon. Okay, class C2, C3, like that. Class C1 within brackets C2 and C3. This is basically it's inheritance concept, but that's how it is. Okay, we'll come to inheritance, but here is L1, an object, is equal to C1. L1 is equal to C1. L2 is equal to C1 as well. So L1, L2 are separate objects. Okay. Classes are just package of functions. Okay. This is the same encapsulation concept. A class is really a pack of functions and methods. Okay. So classes support what? Classes support code reuse. I mentioned that it is a data type. Okay, you can create your own data type with classes. So the purpose of this is code reuse. You could create multiple instances of that class, right? There are multiple objects. In each of that objects, you're using reusable code, okay? And customization of software. So that's the concept of classes. Now, a little bit on to further detail here. How do you define a class? I mentioned class keyword before the name of the class. The name of the class is, it's a convention to put capital K's in the beginning, okay, and rest be lowercase, okay. This is the name of the class. So class person colon, okay, class person colon, and then inside it, there is always a default function, which is called the constructor. Okay. And in Python, you have the constructor in this manner, init. Okay. So def init means it is a constructor. Okay, this is a standard convention or syntax. You have two double underscores before this word in it and two double underscores after the word in it. In Python, the moment you see this syntax, you call it a constructor. Okay. Now, what is a constructor? Constructor is just a method or a function. Okay. I use the name method and function interchangeably. Okay. So def init, okay, with the two double underscores before and after it is the constructor. And what does it do? It has some parameters, right? It has some parameters here. I have the first question with self. Now self is a syntax again. Okay, what it means is it refers to that object, whichever was initialized. Now with this person, I could initialize Sriram, I could initialize Jesslyn, like that. So self refers to each of that object. Okay, so what I'm passing here is self dot name is equal to my second parameter name. Okay, so this is an initialization and it is done inside this init method. This is a constructor. What it does is it creates the initialization for your object. Okay, so for your object, I'm going to pass this self, this first position parameter is always this keyword self, which refers to that object which will get instantiated. That object's name is equal to the name which I passed here. Okay. Same way, that object's gender is equal to the third argument, third parameter gender. Self dot age is equal to age. So this is self referring to that instance of the class or the particular object which will be used. So next, assign each self dot attribute or self dot property to each argument of what will get passed. Self dot name is equal to name. So this whole function, what it does is it initializes the object. Okay, and it initializes the object which it gets created. Now earlier we created L1, or here is equal to C1. So this is the object. Okay, L2 is another object. Okay, but when you define a class person, okay, when you define any class, this default function or the constructor is to be created as a part of this class. Okay, and what its job is, what the job of a constructor is, it initializes this object of this class to the values what you will pass. Okay, I will pass, when I create an object, I'll pass name is Sriram to that object. Okay, another object I create, name is Jesslyn. Okay, so when you pass these values, it will get initialized and you get that object which you can use. Okay, let's take another example, class item. Okay, the constructor is like this. So def init, you have to code this constructor. The first parameter is always self. Self dot item code is equal to item code. Self dot item name is equal to item name. Self dot price is equal to price. So these arguments are initialized inside the class. When you create an object pencil is equal to item, of some specific pencil. Okay, P001 is item code. Faber HB4 is a name, item name, and the price some number. Okay, so what's happening in this line at line 9, I'm creating an object pencil by passing a specific data, and that initializes the constructor inside here, assigns it to the object pencil. Okay, these values are your data and it is available inside this object now pencil. I can refer object dot item code to get this value. I can refer pencil dot price, it will give me the value 200.5. My second object, pencil box, is like that. Okay, box of pens is a different item. Okay, so each of this pencil box, box of pens are my separate objects of the item class. And what it allows me to do is initialize a set of values. When I call this item class, I don't have to pass anything in this self position. This is inside the constructor definition of the class. Whereas when I'm initializing pencil equal to class, it is going to bind this data to be available in this object with the help of the constructor. Okay, is this clear? Any question?
No, it's clear.
Here there are 4 character spaces. This is again syntax. Class item colon. Okay, this def is to be in 4 character spaces. This below the def, the scope is 4 spaces like that. Of course, the colon at the end of the constructor. So that's another example. Class vehicle. This constructor is coded name, manufacturer, speed, name, manufacturer, speed like that. Here is car, an object. Okay, car is a vehicle, right? A truck is also a vehicle. So car, I'm assigning a specific value of the data. Honda, Brio is the car name. Honda is a manufacturer. For speed, I'm just giving a string fast. So truck is also a vehicle. A truck is a vehicle, and this specific one has a name Ace. The manufacturer is Tata, and it moves slow, and speed is slow. Okay, so I'm passing the values for name, manufacturer, speed, assigning it to the object. Okay, bus is Vajra, Volvo is fast. Bike is vehicle, its name is Enfield, manufacturer is Eicher, and super fast. Now, what is the purpose of doing this? I said you can create your own data type. Okay, so now when you print, I can print like this. Print and give an object dot attribute reference. It will give a message like that. The Honda Brio travels fast. The Tata Ace travels slow, likewise. Okay, so this is the purpose of printing it this way. You have bound this data to your own data type called vehicle. The class name itself is your data type name. Okay, vehicle, and now you created your own objects. Okay, the purpose of creating the object, you can use it in any program to refer like that with an object dot attribute reference. Okay, let's move on. Another example of a class, here is class dog. Here is initialization. I could default a value fetch count to 0. Then I'm initializing the constructor. Now, in terms of syntax, the constructor with this def init should be the first function you define inside a class. Inside a class, the first function should be a constructor. Okay, that's syntax of defining a class. I could have other functions, or these are my other methods. Okay, a dog can have methods bark, fetch, sit, and so on. Okay, so def bark, I can pass this argument self. Self, when asked what is self, self refers to the object at the time of instantiation of the class. Okay, it will refer to that specific object. Could be a specific pencil or a pen, likewise. So here in this case, this self refers to that dog. Okay, so self dot name is barking. So I define a function bar, and then here is another function. I'm printing, when called this bar, it's going to print dog is barking. Okay. If I call the dog name Rover, Rover is barking. Rover is 10 years old, breed. Could be a German Shepherd, like that. Fetch, I'm incrementing the fetch count here. Fetch is a function which increments the fetch count. The fetch count is one of the property, and it's the number of times the dog is gone and fetched the stick. Okay, so fetch count plus equal to 1. Every time I call this fetch function or this fetch method, it will increment the fetch count. Okay, so here I'm printing Toby runs and fetches a stick fetch count times. Okay, one time. Another time I call the fetch, it will increment the count to 2 times, likewise. Another function def sit, name dog Rover is sitting with 5 fetches, like that. Okay, so a class. Now here is my object of the previous class, my pet. Okay, I'm creating an object. My pet is equal to dog Toby German Shepherd 2. My brother's pet is another dog. Rover is a breed Gorgi, age 3. So when I call myPet.bar, it will print Toby is barking. Toby is 2-year-old German Shepherd. My brother's pet.bark, Rover is barking. So its initialization is different here. The name of that dog is different. So Rover is barking. Rover is a 3-year-old god. If you call it multiple times, it will go about incrementing the fetch count. Okay, fetch, fetch, fetch. Let's say you're playing with the dog. You are calling fetch, throwing this stick, and dog is going fetching, come back. So each time this fetch is called, it increments the fetch count. Okay, and here is another rover runs and fetch. Finally, you can say my pet dot sit, my brother's pet dot sit. Toby is sitting with 3 fetches. Rover is sitting with 3 fetches. You can increment the fetch count and finally call an output, say sit, to get the result. Okay, so this is the definition of the object, like this. Initialization, the constructor is called internally. So what does the encapsulation do? Encapsulation binds the properties and method, and it hides the code, or hides the complexity of that class by binding the properties and methods. Okay, that's what encapsulation does. Encapsulation, while creating the object, you just call the class. You don't have to look into how the internals of that class is. Okay, you just have to know how to call the object, what is in definitions. The signature is sufficient. You don't have to go into how it is coded and all that while using the object. Okay, so that's the concept of object-oriented programming. Is this clear?
Yes.
Okay, so we'll park it here and we'll get into the code. I just shown that code in the session. We will, okay, so we will continue the collab for the classes in the next session. Okay,
Okay.
all right. Hi, Sriram. Good morning.
Hello, good evening.
Yeah, how are you?
I'm doing well. How are you?
I'm good, thank you. So yesterday we have gone through a concept called object-oriented programming. We looked at classes and objects, and we saw a few examples of how to create a class and instantiate the objects. Okay. Uh, Today, we will do it hands-on in the Collab notebook. Okay. So I will show in my session first, and then you can open Collab and try the same. Okay. So here is our first program. When you create a class, we saw a class is a template of an object. Okay. So the syntax is you have to use the keyword class. Okay, like that. You're able to see my screen.
Yes.
Okay. So the syntax here is class space person. Okay. This example, the P is capital case. Okay. It is just a convention. It's followed in Python that the first letter of the class name be created in capital case. It will not uh, error if you do not create so. Okay, but that's a convention that while naming the class, the first letter is capital case. So the person, the P is in uppercase. Okay, and the colon following that. So class person, then immediately the next line of code, 4-character spaces, the constructor. Okay, so we saw the constructor is a function which initiates that class with this initiate function. Okay, so init with 2 underscores like that. Okay, I'll just show it to you. 1, 2, like that. Okay, and the keyword init followed by 2 underscores. Okay, and then open brackets, the first default parameter is always self. Okay, always self. Now this init is having 2 underscores ahead of it and after it. It's also called the double underscore method. Okay, in short called drunder method. Double underscore is short form of it is called drunder. Okay, so in Python you'll hear them, the developers use the drunder method. It just means uh, double underscores ahead and after. These are some default methods inside a class. So when you create them like this. This is a constructor. We will see another one shortly. So the first parameter is always self. Okay, so self. Uh, then you have name, gender, age. Now these are my specific properties which are getting initialized by this constructor. So then I create the next line of code, again 4 characters indented in the def inside the constructor. So self.name is equal to name. So the value which you will pass is assigned to the object. Okay, self refers to that object which you get created. So self.name, self.gender, self.age. So all 3 parameters uh, is assigned to the object with this constructor. So this is the constructor code. Okay, because def init the parameters and then a colon. Okay, so the constructor is coded like this. Now, this is one double underscore method. Python has another method called str. It's again a drunder method, str, which takes an argument self here. But I use this method. It's available while creating a class. You create this drunder method called str, so that whenever you refer to that object, it will not give you a reference like object 1, object 2, object 3, like that. In the absence of this string method, it will, when you create objects and you try to refer that object, internally Python will give object 1, object 2. But if you code this str double underscore method or the drunder method to return a string, when you call this class, when you call the object of this class, by default, it will return the string. Okay. In typical programming languages, this is like a two-string method inside your own class. Okay. Java has it like a two-string method, whereas here in Python you call an str, which is a drunder method. Why this? Because in the absence of this method, when you refer to objects, it will be like object 1, object 2, object 3. But when you code for this str method, here you can see I've returned self.name is a self.age, years old, gender. Okay. So what it does is it will, when you try to mm, call that object, it will say that, for example, Ravi is a 10-year-old male, like that. Okay. So that's the purpose of a string. It is going to give a string representation of the object when you call that object. We will see that shortly. Okay. So this is also a drunder method. So I introduce you to two drunder methods. One is a constructor. uh, the other one is a string. Okay. Whenever you create classes, these two methods are always to be coded. Okay. Constructor, because it's the default method. But this is optional. If you don't code for the string, uh, internally it will go with references like person 1, person 2, like that. Object, an object reference is with numbers. Okay, but when you code this a default str method, render method, then it will respond this way. Okay, uh, okay. So this is another render method. So whenever you're creating a class, you're encapsulating, right? Encapsulation, we saw the concept of encapsulation is you're binding a property, a set of properties and methods. Okay. So in this person class, I'm having name, gender, age as the properties of this class, which are simply variables. Okay. I'm assigning variable names, right? Name, variable name called name, variable name called gender, variable name called age, and I'm assigning it with the constructor. Now, the method I'm including in this example is just a description method. Okay, so when you code a method, it's a function, def description, uh, self refers to the object. So when you call this method, it will return self.name is equal to, self.name or Ravi is a 10-year-old male, like that. Okay. So we will see. So this is my method inside the class. So we just coded a class like this. Is this clear?
Yes.
Okay. So let's move on. So when I create this class, I'm running this. The class is created. Python doesn't give any response in this case um, because it is in the notebook. Okay. It's in a Colab notebook. Uh, So the object is created. Okay, I mean the class is created, pardon me. So then when I create a print statement, I'm calling this class directly. Okay, so when I call this class, it returns class main dot person. Now if you see, what has happened is it has allowed you to create your own data type. Okay, so that's what the purpose of creating a class is, to bind um, your data. You create your own data type. Okay, so so when you print the class name, okay, like as I'm showing you here, you have a data type. So this is a data type, custom data type, which you are creating. So what it allows you to do is, it allows you to create an object. Okay, now here is one example of an object. I'm assigning some values to ages, and okay, when we see well, okay, you have an example called age equal to 10. Okay, age equal to 10 is a variable equal to value. Okay, so you have a Python variable to the left equal to a value. Okay, city is equal to New York. So these are the ways you have created your value. You assigned the value to your variables before. Much like that, when you create an object, okay, so the data type here is number, data type here is string. But now we have created our own custom data type called person, right? So that's our class. So same way, we're going to assign a value to my object, or person1 is equal to class name within brackets specific value for this object. I repeat, person1, much like you define age and city here, person1 is your variable, which in this case is an object of that class called person, which is on the other side of the equal to. Within brackets, you will pass specific value for this object. Okay, so what we pass here, in this case, the ray M12. Okay, ray M12, hold on, name, gender, age. Okay, so name, gender, age. So this is the first object. Okay, and person 2 is another object, Mary F and 21. So this is my second object. So you see, the objects are created much like the way we are assigning value to variables. Okay, here is another example. I could just have variable names the way I want. So Ravi is a person and specific value of this object. Okay, Sita is another person, Sita female 21. What you're seeing is, when you call and when you create, you're assigning an object equal to class and assigning specific values. So what happens internally is, the constructor, the init method, now receives this name, gender, age, and assigns it to self.name, self.gender, and age. Now that self is now referring to Ravi here. Okay, so Sita. So this is my object here. Okay, and the constructor is called, typically they say the class is created, instantiated with with these values, and a handle to that class is given with this variable, okay, which is the object. So now when I print Ravi, okay, when I print Ravi, here is, I'm just using much like print age, right? I could assign age and print age, it will give you a value. Assign city and print city will give it. Now, much like that, when I can also print the object, okay, print Ravi, what it gives back is this whole string. Now, how did this whole string come off my one variable. Now that's what I was talking about, like str. Okay, so str is my render method, will get invoked when you just print that object. Okay, so I printed the object, print Ravi, right? So what I've coded there will come off as a return to string method of that particular class, that I in string method of the class name. If you coded it in certain way, that method is going to be returned when you just call or when you just print that particular object. Okay, so this is clear to you. Print Sita, it print Sita is 21-year-old man. So the default method of str gets invoked here. If I don't have this code, okay, for str method, it will allow me to still create the class. But then when I return it, when I just print it like that, it will say object one, object two. It will give some person one, person two sort of internal reference. Now, other point to be noted, okay, now, uh, so what you have created is your own data type. Okay, so let me just print here. Uh, okay, type age. So yeah, type age is, it can take an integer, much like that type Ravi would give you a value, which is your own data type called person. Okay. Now, person one we created, right? So person one dot name, you can create an object dot attribute reference. Okay. Person one is the object dot name reference to return the value. Okay, person one dot gender, like that. Okay, so this is the way you invoke a particular property of that particular object. Okay, so Ravi, male 30, Mary female 21. Okay, so is this clear?
Yes.
Okay, now before we move, you can try the code at your end. Okay, so let me see this. Let me share this in the chat. Or this being the first class, you need to get some hands-on. You can refer this, open your notebook, Python notebook, and try to type this in. The first time I don't want to share the code so that it allows you to know while you type it, the syntax and all are familiar instead of me sharing the code. Yeah, I will let it be on the screen. You can cross check. Okay. And yeah, if you have any questions, feel free to ask at that point. Sriram, are you uh, able to get to the class creation?
It's giving me an error, so I'm
Please
trying to.
share your screen. I will
Yeah.
look into. Yeah, I can see your screen. Self return. The self dot name is a string self dot is. It is probably the indentation, but let me see. Def return. No. Yeah, everything is okay on the. Just click before the return. Move it by one character space. No, backward, backward. Yeah, one more. Yeah, now Do the same on this row 11. Yeah, run it now. Comma. You return everything. Yeah, that's one. It's sometimes difficult to see where the error is. Yeah, the colon after the def. Right. So that yeah, the class is created now. Yeah, you can print person. Yeah, so that's your data type. It shows like class main dot person within quotes main dot person. So you created your own data type. Very good. Now to yeah, that worked. Yeah. So it has Python is pretty rigorous in syntax. At the end of each def is a colon. Okay. So that's a good one. Okay. So let me share my screen now. Okay. Yeah, you can create person one like that. Person one is equal to person within brackets, pass some specific value like yeah, create a new cell and then go into that. Person one, person two are different objects. Ravi and Sita are also different objects. Are you getting the output?
I'm entering the.
Yeah, you can share your screen. Let me just stop sharing. Okay, now person. Okay, well, yeah, Ravi is equal to same way person. You can copy line 4 and change the data. Yeah, yeah, okay. Yeah, put some, yeah. So you're creating another object. Yeah, another object. Okay. So then you're printing. Yeah, if you run this cell, now you can print Ravi and print Sita. Not the capital one. The object here you're going to print is yeah, small case. Okay, okay. Yeah, print. Actually, you can put it in separate prints, but okay, run this, no problem. Print will allow. Uh, it came in the same output because you're printing one after other. But yeah, the print can allow different arguments. That's okay. But normally you're printing separate objects. Okay. Okay. So So that's your output. So what is happening at this point is your string render method is getting invoked. Okay. Um, Very good. Okay. Now, for a moment, yeah, let me show you. Hold on. Yeah, and then you can also print Ravi.name, Ravi, Ravi.gender, like that. Invoke the object.attribute reference, like person1.name,
Sir,
yeah, let me show you a screen. Hold on.
yeah,
So here we came this far. You can see my screen, right? Print
yeah,
theta dot description. So you are invoking a method of that object. Whenever you are invoking a method, it is like this: object dot method name, and you have to use the open and close brackets. So this is my uh, it's a function or it's a method of that object. Okay, here is other references of your object: person1 dot name, comma person1 dot gender, person1 dot age. Likewise, you can print separate object attributes. Try this at your end. So here is the example where I just created the same class. Hope you're through with the print of the attributes, right? Just let me know when you're through with this print.
yeah, it worked.
Okay. Now I wanted to tell you what this string method I was saying no. When you're not coding for this render method, a class will still get created. Okay. However, now I created the same class. I commented this lines of code. I ran that. Okay, the class got created. Uh, when again I went in to create the object, okay, person1 Ravi Sita, but when you print that or when you call that reference of the object by printing Ravi, here it no longer returns that that string of that particular class, okay, because we commented that render method. So then the person object is having a reference like this. You see it, person object at, it's the address of that object. Okay, so Ravi and Sita are two objects. It'll give you like object, I told you object 1, object 2, but actually it's taking the internal address of that particular object reference. Okay, so yeah, so that's the default function. When you're calling the object alone, it has a reference to that address shown like this, person object at that. But when you code this string method, it is giving you that friendly message which you saw earlier. Okay, is that clear? Each object is stored at a certain reference. So that reference number is this hexadecimal value or this character values. So now I comment back. Whenever you modify something in a class, you have to recreate the class. Not just that, you have to recreate the object references because now it's a new class. Okay, the earlier person class, uh, we just before this modification did not have the string method. Uh, it, it is a new class now, but my object references are pointing to the old person class. So I have to recreate my references. Here, person1 is equal to person. Ravi is a new reference now. Now when I call it again, it'll give me the string methods output. Okay. So is this clear?
Yes.
Uh, uh, okay. So okay. So let's continue. We saw another example of an item class. Everything the same. Okay, we have just a different uh, item. It could be an item inside your store or anything like that. So item here refers to an object in your store. Okay, I have different items, pencils, a box of pencils, box of pen, like that. Okay, so constructor. Okay, everything following the same. The init, the self is the first argument, the first parameter here. Item code is an internal um, item, the store number, item number in my store for this item. Okay, so this is an item code, item name, price. Okay, so we have coded the constructor and the class is created with just the constructor. That's all right. Okay, so here pencil is equal to item. Okay, pencil equal to item. My first item is having an item code like that, P1001. Apsara is the name of the pencil, and 9 is the price. Okay, box of pen, item 2, name of the product or name of the item is cello, and the price is 210. So these are two separate objects. So I create this and I can print pencil dot item code. So object 1, item 1 dot item code, like that. Okay, box of pens dot item code. So there you have two items in my store, like that. Okay, is this clear? So the constructor is, what does a constructor do? It initializes um, the object with the data which I'll pass while instantiating this object. Okay, the classes uh, the instance of the class is created here, right at this line of code. The instance of the class is created, and the object is the value I'm assigning to my variable. This is my object. Okay, same way, box of pens is an object. At this line of code, a new item is created with this data, P1002, cello, and 210, and a handle to that particular object is uh, available with this box of pens. Okay, these are different ways of uh, you know the terminology used in object-oriented programming. They even say there is a uh, handle of that class is the object. A new instance of that class is given a handle, which is the object. Okay, these are different uh, jargons or different ways of referring that particular object. Some call it a handle of the class is given to in the object. Okay, simply it's variable equal to your data. Okay, okay, yes, you can create this. Are you Able to get it, Sriram? You can share your screen.
Yeah, I'm sharing my screen.
Okay, pencil dot item code. So that's where it is. The first argument there after print pencil dot item underscore code. Yes. Box of pens, item code, item name, box of pen. Yeah, 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 that worked. Okay. Okay. So a quick recap here. Uh, class is the item name, right? So class is the template of the object. Okay. Here the class is item and, and box of pens and pencils are individual objects of the item class. Constructor is this def init, okay, and it's always the first function to be coded inside the class. That's a mandatory thing. And the first argument of that constructor is always self, okay, and then the rest of it is the parameters which you want to initialize. So that's the code which you have just written, okay. Okay, you're getting a hang of this object and item classes and objects.
Yes.
Okay, okay. Now I'll share my screen. Yes. Very good. Here, what I've used here, sometimes you want to refer to okay, item code came out of my own coding, P1001, P1002. I just pass some value like this. But when you create your own object, sometimes you want to use some internal sequence numbers. Okay, internal sequence numbers. Often when you are creating some employee ID and all that, or any internal reference number, you don't want to manually set these values. Rather, you want this to be generated. Okay, so here is a portion of code called UUID. This is a module. Okay, this is a module. So you import UUID, and then when you print UUID dot UUID1, this will give you an alphanumeric uh, object reference or internal sequence reference. Mostly this is some unique ID. Okay, unique ID is the UUID. So you can also call it unique user ID. Okay, that's the W, unique user ID. Often when you have to generate a sequence, okay, which is randomly generated. Okay, this is not having anything. This is a unique reference. You can print like that after you generate the string, except that this is a string conversion. Okay, so print, it will generate the string like that. So this you can think of it like it's a random generation. Another method of this is UUID4. Okay, this is another function which will uh, generate likewise. Okay, so here is UUID4 being printed. Okay, and I could sometimes, if I don't want a very long part, you can see there are some few parts of this code. I think it's an encryption of 256, but if I want to only take the first part of it, uh, I'm just taking string slicing. Okay, so seek is my UUID, unique user ID 4. And suppose I want to take the first slice alone. That's the first 10 characters. SEQ, open square brackets, colon 10. What it does is starts from the beginning. Anytime in a slice you see before the colon an empty space, it means it's from the beginning. Likewise, if you see if it is at the end of at the right side of the colon, it's till the end of the string. Okay, so I'm taking the first 10 characters here. Sorry, first 9 characters here. This is a 9 character that end number of the slice is not included. Okay, first sequence like that. So you can use unique sequence IDs like this. Where to find all of these modules is okay. Either you can, I think you can do help. Let me see ID, or you can go into this location pi.org. This is a Python modules can be searched here. Okay, so Python package index and so UUID. Okay, and it's and click search here. So there are several of them. It's for the unique user ID encoding. Okay, UUID module. Many of them have written. Let's check one. Okay, I'm taking some random one. Let's take one like that. Okay, he's giving how to use it and all that. UUID4 is a common representation, whereas, yeah, this is another 25. So typically when you want unique values, you go ahead and it's available, or you could install your own UUID module. This is going to give, I just imported, right? So let me just go in and say help UUID. Okay, so UUID, more about it is here in the help. Okay, so it's a way to generate universally unique identifiers. Okay, so universally unique identifiers, doc library like this, he comes over here. So open, you can also open the link like this. You go to the UUID reference. So you could use either UUID 1 or 4. Yeah, this gives you the generate a random user ID. Normally, this is what's followed, UUID 4. Get node, a 14-bit sequence. Okay, so there is something called SHA hashing. That means every address, like MAC address of the computer and all that, this generates a unique user ID. Okay, and it follows some algorithm. Either it's SHA, which is an algorithm, hashing algorithm. That means some way this is a unique identifier, so that there is no clash between two codes given randomly. Okay, that's the whole idea, that everything to be having a unique identifier. Okay, so that's this module called unique user object. So what you can do when you're creating some database, if you want to give unique numbers, even you can assign such unique numbers out of this UUID model. Okay. Uh, yeah, is that clear? So this how sometimes you might see such applications like Bitcoin. So when you're creating a unique address, you will see this sort of a unique address. Okay, alphanumeric. So then it's generated out of this sort of a random generating user ID object with some algorithm. So UUID 5 is SHA-1. It's an algorithm. Yeah, much like MAC addresses and so on. Okay, so that's a bit on unique numbering and the database. You might create it like database objects, and sometimes you want a sequence. So that's when you can randomly create this. It's so easy to generate that user ID in this manner. So this is alphanumeric. Okay. Yeah, UID is a SHA-1 hash algorithm. Okay. Okay, so that's one. Okay, I will just remove this here to get our space back. Yeah. All right. So now what I'm doing here, I've created the vehicle class, okay, with name, manufacturer, speed, okay. Um, and I've created a drunder string method. So in the string method, I have put this UUID str of UUID 4, the first 9 characters. Okay, so then it, and then I created an object. Car is a vehicle, truck is another vehicle. Okay, passed a specific data. Brio is the name of the car. Honda is a manufacturer. It's the speed. It's not a number. I'm just giving a string now. Fast. Truck is a vehicle. Ace is the name of the mini truck. It's a small truck. Okay. And Tata is a manufacturer and it goes slow. Okay. So then I can print like this. The Honda Brio car moves fast. The Tata Ace truck moves slow. Okay. But now when I print the car and truck object, you can see there is a hash uh, generated like this. Okay. Because when I did the string, I've generated a unique ID, which could be some unique ID to refer that particular record. Okay. Often in database applications, you might want a unique number, which is a random number. It doesn't have any, it has to be a unique number. Then you can use this str, use UUID 4, and once that string is there, I'm taking a string slice to generate an output like this. Okay, so that's the unique ID and this is the unique ID. Okay, okay, so is this clear?
Yes.
Okay, so what you can do here is UUID, you can try this import first. I'll put it in the chat. You open a new cell and just run this to get the output.
I got that.
Okay, so that's your sequence for the unique value. However, here we are creating a vehicle class. So let me put that in the code as well, the chat. This is for the vehicle class, and it is just as we are creating a unique ID when I call for this object. This is the code for the vehicle class. Okay, once you get this output, this try to print car and truck. Again, I'm in the chat assigned to these. You will see the unique IDs come through.
See them. I see
But
them.
are you getting the unique IDs?
Yes.
Okay.
Yes.
Okay. Okay, Sriram, you have a good day. Enjoy
Yep.
your, yeah. Have
Thank
a
you.
nice
Have
day.
a Yep. Have a good.
Thank you. Thank you. Bye. Bye.